Right, folks, let's get going. Welcome to the session, Developer Mindset, Embracing GitOps for Network Security and Compliance. So my name is Gunnar Gorch. I am a developer advocate at AWS. And, well, we're going to talk about GitOps and how that can help us with security and compliance. We cannot update the network. The business doesn't allow it. Or every time we implement a network change, something goes wrong. Common phrases that you might have heard when we're dealing with network, infrastructure, and security. So as we've seen these modern cloud-native applications evolve, the traditional way of doing network testing and security compliance has perhaps not really kept up with how we are evolving applications today. So I want to talk about how GitOps can help us with this to make sure that we are compliant, that we are building and updating in a secure way. I'm going to do it by quickly introducing you to GitOps and then show you some of the tooling available, both from third parties, from partners, and from AWS. And then I'm going to show you an example architecture. This session could also be called how to do a 90-minute session in 25 minutes, so try to keep up. All right. I think having that developer mindset is really fundamental if we want to leverage GitOps efficiently. Because we need to think as developers when we are using this approach. We need to think about using infrastructure as code. We need to version control everything. We need to think about testing, automation, validation. We need to use these different practices that we have been using for development for quite some time. CI/CD. We need to think about how to empower people to actually make these changes so we don't end up in the we can't make changes because people don't really allow us to. So embracing the developer mindset is fundamental. So then, what is GitOps? Well, it is a methodology that then allows us to use Git version control as a way to make sure that we are doing infrastructure automation and management, allowing us to use software development principles when we are deploying, when we're managing, and when we're securing our cloud infrastructure. So we are going to use Git. We are going to use infrastructure as code. We are going to use CI/CD pipelines to make this possible. And, well, I touched on a couple of this, but I think this is a common mindset that we see when it comes to these things. Well, first off, why should I care? I work with network. I work with security. Why should I care about this? Or the network in our application, our enterprise, our company, it's too important to make any updates to it. And the last one is my favorite. Person X is on vacation, so we're not going to make any changes while that is happening. So let's look at some of the problems that GitOps solves just in general before getting into the specifics on networking and security. First off, it addresses the problem that is automation complexity. Automating things is complex. It is something that we strive for, but automation in itself doesn't make things less complex. And if we look at different approaches that we've had throughout the years, starting off with manual updates, manual ways of building things, well, super easy to get started with. You can use the AWS console, just start building things. Perfect. But it's hard to reproduce. Make changes to it, well, you don't really know what will happen. You can't really test it easily. And it's time-consuming for people. The second approach that we have seen being used is scripting. So we're using different types of script to make this automated. Well, what happens if the API call doesn't really work while we're running our script? Or how do we make updates to something? We have scripts, we make changes to those, we perhaps have inputs in the scripts, and so on. And how do we know that things are actually ready to be able to run these scripts against? How can we make sure that the scripts that I've created works for, well, Joe, who was on vacation? Then we started turning to using different types of tooling for resource provisioning and then different type of engines. It's easier to automate that way by using these types of tools, but it's also possible for us to reproduce because we can run them over and over again, but there are still issues with it. It's perhaps difficult when we have issues to do rollbacks, to be able to actually know what's going to happen if we fail and we need to do a rollback. And that's when we started moving into the declarative approach to it by using things like infrastructure as code, using CloudFormation, using CDK, using different types of tools that allows us to do these updates in a more secure way so we can make these changes. The second problem that we're trying to solve with GitOps is consistency. Being able to do these things over and over again. Because yes, we have implemented infrastructure as code, so that means that we can do updates by simply updating a CloudFormation stack or by using CDK or whatever tooling we're using. But it's quite common that these things are spread out across the organizations. We have different people updating different stacks. They have their own version of the code, perhaps not linked to whatever the other person is working on, and making sure that things are consistent is a problem that people kept facing. So GitOps is there to help with that problem. And then, of course, versioning, making sure that we are using the same version of the stack. We are working with updates that everyone is using and making sure that we have. And then also knowing who did it. Who is making the updates? Who have made these changes? Well, another thing that we know from software development that Git is good at, we know exactly, I know it's a Git term, so we know who to blame. So I think we can say blame, even though we're not going to blame anyone. But knowing exactly who has made changes and what is the correct version, Git is there to help. If we then look at it specifically for infrastructure security, what are the different types of problems we're trying to solve there? Well, one is configuration drift. So GitOps will help us to make sure that the desired state of the infrastructure is declared in that version-controlled repository. So we don't have this configuration drift within our infrastructure. Configuration drift meaning that we have deployed a version using CloudFormation or similar, but then changes happen because someone else is making an update. Someone is using the console to make a change or using the CLI. All of a sudden, it doesn't really match up with that CloudFormation template that we deployed in the first place. So this, of course, increases security risks if we have drift, because the untracked changes, well, we don't really know what they are. What are we exposing our infrastructure to? If it deviates from what we created as our security model in the infrastructure, we don't know what kind of threats are out there. And it obviously makes it harder with compliance. A lot of companies work in different types of regulated industries. They need to be compliant with whatever framework there is out there. But if we can't say exactly the state of our infrastructure, it's hard to be compliant. It's hard to do auditing of the infrastructure. And for everyone who's been involved in troubleshooting errors sometimes, well, super difficult if we don't know the state of our infrastructure. If we have templates, if we have version-controlled templates of our infrastructure, we can easily spin up a test environment to be able to try and troubleshoot, try to find fixes for issues. If we don't know, well, that's difficult. And it's not very efficient either. So we have to spend extra time on troubleshooting, supporting, spend extra time on testing everything before we make any types of changes. So we waste time on things that we shouldn't really be wasting time on. And one of my favorite areas when it comes to infrastructure is reliability. And not knowing the state of our infrastructure, well, that is definitely going to lead to reliability issues over time. We don't know what might happen because You've all probably heard Werner Vogel's phrase that everything fails all the time, and that happens in infrastructure. So knowing what the state of the infrastructure is key to being reliable. I mentioned compliance, and compliance and auditing is one of the other issues that we want to solve by using GitOps for network security. So by having this practice in place, we want to solve this issue. So for instance, knowing what type of standards we are using today is difficult if we're not using a version-controlled way of handling our infrastructure. And knowing how to actually do a report of the infrastructure we have is difficult if we don't have this in place either. And like I mentioned, many companies are working in different types of regulated industries. And if we can't prove to whoever the auditor is what the state of our infrastructure is, well, it's going to cause regulatory issues for us. We need to have verification of what the state is in many cases. And then the security posture, of course. If we have non-compliance, well, there's a huge risk of security breaches in different ways. We need to be able to have control of our infrastructure to know what the security posture of the infrastructure is as well. And then I touched on this before as well. Being able to operate our infrastructure, being able to have support staff, our DevOps engineers, or whatever the titles are, and be able to then operate our infrastructure, well, if they don't know what the state of the infrastructure is, it's going to be difficult for them to be able to do their job as well. It distracts people from doing the things they're supposed to do. And more on the security part then is being able to do security scanning and policy enforcement is also difficult without having proper infrastructure practices in place. So we can then integrate different types of security scanning and check our infrastructure as code with the help of these practices. So let's say we are deploying something with infrastructure as code, with the GitOps practice, well, we can do security scanning while we're deploying it, just in the way we usually do with our code. When we're deploying code to production, we are usually checking that before we push it to production. You should do the same when it comes to these practices as well. And we can then make sure that whatever we're deploying into production is compliant with our security practices. When we're talking about deploying infrastructure, being able to roll back and recover to the previous state is a key factor. So it's common practice when it comes to software development that we should be able to deploy something into production. But if it fails in some step, we should roll back to the previous state. This should be the case for infrastructure as well. So if something fails while we're deploying, it should either automatically roll back, or we should have rollback procedures in place to be able to do it. This, of course, minimizes downtime for us because we don't have to worry about deploying something that doesn't work into production. If we do, we're able to roll back. And that, of course, also means that we can maintain the security integrity because we're not deploying things that are broken. And yes, I know there are other security concerns, of course, but it at least makes sure that we don't deploy things that are broken from the beginning. And finally, back to resilient. It enables us to quickly respond to resilience issues as well, no matter if it's errors in the infrastructure or vulnerabilities from a security perspective as well. One of my favorite things when it comes to infrastructure is something called immutable infrastructure. And with the GitOps practice, we're able to have immutable infrastructure in place. What that actually means is that instead of modifying existing infrastructure, we're basically deploying new infrastructure that replaces the old version. So just like we can do blue-green deployments when it comes to our code, deploy something new, switch over to it, we do the same with infrastructure. GitOps allows us to use immutable infrastructure so we can quickly deploy a new infrastructure stack. We can switch over to it when we see that it is in place. But it also gives us several security enhancements in the fact that we are not making changes to existing infrastructure. Instead, we're deploying new versions of it. So we don't have to have the same type of access to that infrastructure because we don't have to make changes to that infrastructure, which is good from a security perspective. So let's look at some of the tools that we have available to be able to then solve these types of problems with the help of GitOps. So if we look at a common GitOps stack, it looks something like this. First, we need to have the versioning part of it. And that's the Git part of GitOps, I'd say. So we obviously have AWS Code Commit. You can use GitHub, Code Catalyst, GitLab, Bitbucket, or whatever type of versioning system you want to use. Self-hosted, I guess, is an option as well. So then you have your infrastructure as code, you're storing it in a repo somewhere. The next step is then to, well, you have somewhere to store it. The next step is to then choose what type of infrastructure as code solution you want to use. And there's several options there as well, of course. CloudFormation, AWS CDK, or AWS SAM, the serverless application model, or third-party or partner solutions like Terraform, Pulumi, Crossplane, and so on. This then allows you to write that infrastructure as code and allows you to store that in your versioning system, your Git. And then the third one is the CI/CD part of it, where you're actually taking that infrastructure as code, fetching it from your versioning system, and then deploying it as infrastructure. We have the different code services from AWS. But once again, you can use third parties as well. Use GitLab. You can even use Azure, GitHub Actions, if you please. And these are the different parts of the GitOps stack that we're using. So looking at it specifically from an AWS lens, well, AWS Code Commit for our Git repository, or Amazon Code Catalyst would be the ways of doing it within AWS. For infrastructure as code, I mentioned the three, CloudFormation, CDK, and SAM. All three are using CloudFormation as the base of those infrastructure as code solutions. And then the code services, code build, to be able to build your code, use code pipeline to then work through the steps of your deployment solution, and then code deploy to actually deploy into, for instance, EC2 instances, or to be able to do testing of your infrastructure and so on. And once again, Code Catalyst is there as an option as well. All right, so we looked at what GitOps is, we've looked at the problems we are trying to solve with it, and we've looked at some of the stack that we can use for this. So let me show you an example of an architecture. This one is built using CloudFormation. So we're starting out in the dev stage of things. So let's see if the animation is with us. First step is that I, as a user, is pushing something into my Git repository. I have my infrastructure as code, pushing it into AWS Code Commit to store it, version controlled. Next step is that this triggers AWS Code Pipeline for me to start a new pipeline execution. Code pipeline will consist of a bunch of different steps. The first step is that it is going to use AWS Code Build to store, it's going to store my artifacts in S3, and then it's going to kick off AWS Code Build to actually do something with this artifact. In this case, we can put in different types of testing. We can check the infrastructure as code to make sure that it is compliant from a security perspective, that it's working in the way that I want it to. So it's going to kick off a container within Code Build that is then doing CFN lint to check my CloudFormation infrastructure as code. We can do linting, we can do nag, we can do a CloudFormation deploy when we're done. CloudFormation deploy means that we're going to then deploy all of this infrastructure into a dev account. The dev account then spins up all of the infrastructure needed, which then is sent, in this case, to a manual approval step. So we have a dev environment built with that infrastructure, and Maybe I get a message telling me that I should approve it. Someone else approves. They get that notification. They check the infrastructure, make sure that things are working as intended. That then kicks off AWS code build again, who is spinning up a new container for us, and then running CloudFormation destroy, basically removing that dev account, because we've now approved that the infrastructure is okay. That, in turn, then, switches over to, is it with us? There we go. To our production stage. So we had the approval stage, we destroyed it. It's kicking off AWS code build for us again, the next step in the pipeline. Spins up a container and runs CloudFormation deploy again, but this time towards our prod account. So this is an example of what it can look like and how it typically looks. That we are spinning up infrastructure, we're testing the infrastructure to make sure that it works as intended before then moving on to different stages. We can put in more stages if needed, depending on what your infrastructure looks like, how your setup is with teams, and so on and so on. But doing it this way means that we have version-controlled infrastructure as code. We have a controlled way of deploying the infrastructure without anyone having to log in to different EC2 instances or make configuration changes in the console and so on. So if we then look at how this will actually look in our pipeline, just repeating some of those steps, is that we have our CloudFormation template, like this. It's YAML. This one is creating a security group and a VPC endpoint and some other stuff. I've written this. I'm pushing it into my repo, so creating a new commit to the repo, which then, super blurry, kicks off my pipeline. If you squint, I think it'll look okay. It kicks off my pipeline, which fetches the source and then starts doing those steps that we just showed. So it's building and it's deploying to my dev environment. It is then sent for approval to someone who then gets a notification and approves, which means that it's then gonna reuse the same artifacts and deploy that into our production environment. If whatever we deployed into dev didn't work as intended, well, this would happen. Instead, we're rejecting that update. So the system engineers, the people who have created that infrastructure, they basically get notification back telling us that, nope, this isn't approved to put into production. So it basically stops there. It doesn't go on and deploy this into production. There was recently a very cool enhancement of CloudFormation, something that went a bit under the radar, but some of you might have seen it. It was a new addition into CloudFormation that introduced Git management straight away in CloudFormation. So we're able to take part of what I've showed here, but basically do it straight away in CloudFormation. So when you create a stack in CloudFormation, you can point that stack towards a Git repository. That Git repository will then contain some of these parts that I just showed. For instance, the infrastructure as code, whatever you want to deploy, but you can also then start using, for instance, you can use GitHub Actions to run these tests that I talked about to be able to make sure that the infrastructure looks okay before deploying it. You can use different, if you create different versions of your application within your Git repository, different branches, you can then deploy this into different stacks as well. So you have your dev environment, your staging environment, and eventually your production environment. So that's a cool enhancement that helps us build things using GitOps on just using CloudFormation. So in the abstract of this, it also mentioned generative AI. And I wouldn't be an AWS employee if I didn't talk a bit about generative AI. So I'm just going to show how we can use that as a way to actually enhance some of these practices as well. So let's add in some generative AI. Some of the early things we can do, of course, is that we can use when we're writing our code, no matter if it's CloudFormation or if it's CDK or if it's Terraform, we can make use of Amazon Q or Code Whisperer as a way to make sure that we're creating proper code, or CloudFormation or YAML or whatever we're using. We can also make use of Amazon Q to actually test the things we've written straight in our IDE. But a very cool use case is to use generative AI in our pipeline execution as a step. So we're actually using generative AI to test our code and to make sure that it's proper. So what we can do is add a step in our pipeline where we are calling on Amazon Bedrock and make use of a foundation model to then test that code, asking that foundation model to verify that our infrastructure as code is working properly. That's going to be by using AWS Lambda, invoke Bedrock, and then get a return an answer. Yes, this looks okay, to move on. So we can then, for instance, use CloudFormation to describe the example here is to describe the differences and send to Bedrock. And then create internal documentation to it as well. So not only describe or make sure that it's okay, but we can create documentation around this. And it can add it to Git so that we have proper commenting and so on as well. So generative AI is a practice that I think will be helpful when it comes to GitOps. All right, but besides this, there's obviously a lot more. 25 minutes isn't much to cover GitOps in practice. So if any of you happens to be at Reinforce in June, you should catch the long version of this session, which is a code talk where we will actually do this more in practice and actually build pipelines, and we will give examples of how this works. Session NIS 341. And with that, we're at time. I want to thank you for joining, and hopefully we've removed some of those we cannot update the network or we can't do things because Joe is on vacation by implementing these practices. I'm on all the social medias. Just look me up. I'm happy to connect, and I'll be around for questions afterwards. Thank you all so much.